All right, ladies and gentlemen, today we are going to take a look back one more time at our complex numbers, our I, and our graphing of quadratics, not only to use shading to find solution sets, but also to be able to look to see what the interval notation is going to be. The quiz tomorrow that you get will look something similar to this, shorter in nature, but as you can see up at the top, our goal today is to work through a lot of the odd problems together. And then the evens are going to be you. And again, you're going to have tons of good examples here if you take the wherewithal to write this stuff down and kind of see what's going on. This video will also be available on the YouTube page and off the website later tonight. So, when we're getting involved with I, a couple of things I really have to watch for. First thing, and we've talked about this before, if I see pluses and minuses between my sets of parentheses, between my quantities, I'm just combining like terms. So all I really have to think about on a problem like number 1 is distributing this negative through, basically just changing the signs on whatever's inside of it, and then going back and finding the like terms. Now remember, standard form, when we're doing complex numbers, is to put the constant term first. So negative 6 plus 4 would be negative 2. And 8i plus 2i would be 10i. Notice no I squareds because I'm not multiplying. And that's all I'm basically doing here. So when I'm working my way through, again, if I see a minus, I will distribute that through and take a moment to actually rewrite it. Because by rewriting it when you change the signs, now you're less likely to make a silly error on something. Once you've distributed, again, go back, look that stuff up. 1i plus 2i is 3i, and I'm set. These don't have to be complicated. If I treat the I sort of like I would treat an x value, I can. However, once we start to multiply, see, nothing in between the parentheses, nothing in between the spaces, what I'm going to do, in this case, since I have an extra term, I'm going to go ahead and I'm going to multiply these together first. So 2 times 6 would be 12i. But now again, since there's no spacing, it means I'm going to distribute. It means I'm going to multiply. So I distribute. And I'm like, okay, 84i, 12 times 5 is 60i squared. And then I have to stop and think for a minute. I'm like, wait a minute. I squared equals something. We've talked about this before. Oh, I squared, what does that equal? What? Oh yeah, I squared equals negative 1. So anytime I'm working on a problem and I see I squared, what I'm really seeing at that point is that value times negative 1. 60 times negative 1 is negative 60. Now, if you left it like that, I wouldn't mark it wrong. I'm going to rewrite it, though, in its standard form. This is the preferred answer, but again, if you don't write it that way, if you wrote it 84i minus 60, you'd still be right, okay? And that would be okay. And then to what I'm finding more and more for some of you is a nemesis. So we really want to take some time here to fix this. When we go to FOIL, a lot of you, when you start to try and draw the lines and you're putting them all over, you kind of get lost and you might repeat one that you didn't mean to. You might forget one completely. Here's a way to avoid that. And it also is a nice organizational tool and keeps your work neat. If you make a little 2x2 box, take one of your quantities, one of your sets of parentheses, put it down one side, put this down the other. What I'm going to do is I'm going to multiply what's on the outer edge of the boxes to fill in the box. Then I'll have all my terms ready. So again, we're multiplying though. 7 times negative 6 is negative 42. 7 times negative 3 is a negative 21 with my I. Don't want to lose that. 5 times negative 6 is negative 30i. And then 5 times negative 3 is negative 15I squared, because it's I times I, going into my last box. So before you go to combine like terms, remember, I squared is negative 1. So this really says negative 15 times negative 1, which would be positive 15. Because now when I go to find like terms, I can go, oh, negative 42 plus 15 is negative 27. And negative 30I minus 21I, we're not multiplying anymore, we're just combining like terms. If I owe somebody 30 bucks and I borrow 21 more, now I owe him 51. That's the simplified form. I can't leave it as I squared when I know that I squared equals negative 1. So just something to be aware of. That kind of brings us back through some of our I stuff. We'll come back to more I's in a bit here. So then we get back to what we were working on a little bit more yesterday. Sketch the graph of the function, name the vertex. Remember to shade because there's inequality arrows here. So little things. So just like we did yesterday, we need to find our vertex first. So again, to find the vertex, our x value is going to be negative b over 2a. So I look and I go, okay, so my b value is 2, my a value is negative 1 so far. So I stop and think for a second, because again, I got to be cautious. Opposite of b, opposite of 2 is negative 2, over 2 times a. 2 times negative 1 is also negative 2. So my x value of my vertex is 1. Now again, this is just me. I will show you your options, and then you can kind of pick how you want to do this. To me, to find y, I'm just going to take the calculator, and I'm going to plug this 1 in where the x's go. Now, I got to be cautious. The negative this time is going to be outside my parentheses because it's already here in the problem. I'm not substituting a negative value in. So plug that in. 2 times 1 plus 1. Okay, so I find out my y is 2. So my vertex is at 1, 2. Now we talked a little bit yesterday about how I can do the pattern. Now I got to be careful because this one, since it's negative, is going to open down, but the pattern would be the same. So we talked about how you could go up 1 over 1 while I'm going down, so I just go down doing it. Down 1 over 1. Down 1 over 1. You remember what the next part of the pattern was after down 1 over 1? Hopefully somebody said down 3 over 1. Down 3 over 1. And then I can start thinking about my line. Now again, the or equal to means it's going to be solid. And before we go to shade, I know some of you are thinking right now, well, what if I forget the pattern? Am I screwed? No. All you got to do, if you're not comfortable or you forget the pattern, is go to y equals, type in what you have, and then do second graph and get the table up. But get your vertex number in the middle. And you'll get all the same values. And you can do it that way, okay, and plot your points. Nothing wrong with that. So now my last part, once I have everything sketched, is I've got to do my test point because I got to figure out where to shade. Again, your test point can be anywhere inside your parabola. So I happened to choose for this one 1, 0. And again, the 1 is my x, the 0 is my y. So I just plug these values in. and figure out what that answer is going to be. And the nice thing is, if you choose a number that's right underneath or right above your vertex, you've already done this up here, back when you did the vertex. Oh, so I'll just take the number that I got from my calculator on this side and then ask myself a question. Is 0 greater than, and I know it's greater than because the arrow is eating this side, is 0 greater than 2? Well, no, that's silly, Harty. That makes no sense. Okay, so that's false. And when it's false, we're shading outside of our parabola. Okay? So there's a few things to remember. Okay, type of line. If the or equals there, it's solid. If it's not, it'd be dotted. And then my test point. If it's false, we shade outside the parabola. If it's true, we shade inside. Again, we're going to get some practice. We're going to try a few of these just to make sure we're on board here. Okay, now 11. Again, got to have my vertex. And sometimes just writing the word like vertex and seeing the formula and working it through can make it kind of start to stick in your brain more. So don't try to skip steps here. Write the extra things now so it'll click for you later. Okay, so my A is -3. My B is -12. Okay. X equals negative, I'm actually going to write that out, negative B over 2A. So the opposite of B, the opposite of -12 is 12 over 2 times A. 2 times -3 is -6. So my X is -2. Now I'm going to warn you. Our pattern, our 1, up 1 over 1, then up 3 over 1, only works if there's no number in front of x squared. There is a pattern for other numbers, but I don't want to give you more to get confused. So if there's a number in front, here's what I want you to do. I want you to go to y equals. I want you to type your expression in. And I want you to use your chart. Now, since I know what the x value of my vertex is, I'm going to go ahead and use the chart to get my y. So -2, 1. And then basically, I'm just going to use the values on the chart, at least the ones that I can fit on the calculator here, to make my other points. Ooh, I almost got a little too quick there. Once I have my dots, what type of line am I going to use to connect them with? No line underneath, no or equal to. I gotta go dotted. And then again, for my test point, it can be anywhere as long as it's in the parabola. So let's say I go down here. So this time it looks like we are going to test -2, -4. Again, my x and my y. So -4 is greater than -3 times -2 squared minus 12 times -2 minus 11. Okay, I got to get some calculator help on this. All right, so let's see. -3 times -2 squared minus 12 times -2 minus 11. Dang, all that for 1. So is -4 greater than 1? No, it is not. Outside. So again, as we do these, That's the process we're using. Now here, 13, this is nice. We get one in vertex form. Like, what's so great about that? Great thing about that is I don't have to use the formula to find my vertex, because I just take it from here. Again, it's the opposite of h and then k. Only the opposite of what's inside the parentheses. So like, okay, so -3, -2. Nice thing, I can type this into my calculator, but my a value is back to being a 1, so I can use the pattern if I want to. So I'll show you both here, just in case. We're going up, so we go up 1 over 1, up 1 over 1, up 3 over 1, up 3 over 1. And again, if you're not comfortable with that, nobody's saying you have to do it that way on this. If you're more comfortable typing it into the calculator, except you actually got to type it in the right way, there we go, and using the chart, but again, I got to have my vertex in the middle. But again, you get the same values. At -4, I'm at -1. At -2, I'm at -1. At -1, I'm up at 2. And at -5, I'm up at 2. So I got the same values. What type of line are we going to be using to connect the dots with? We have the or equal to. So this one is going to be solid. Pick yourself a point. Okay. I'll go right here. So I'm going to test -3, 0. X, y. So 0 is greater than or equal to -3 plus 3 squared minus 2. I can do this one in my head. -3 plus 3 is 0. 0 squared is 0 minus 2. Is 0 greater than or equal to -2? It certainly is. I'd rather owe everybody nothing than owe them $2. True, we're shading inside. And we'll be seeing some more with the parabolas here in just a minute. I want to make sure that we're going good with things, that everything's going nice, we're getting some good practice in. So now we're going to go back to our I values for a little bit, so we can get rid of the calculator. Simplify. No I in the denominator. Okay, to take care of this issue, we multiply by what's called the conjugate. And again, what that means is we're going to multiply, and the only thing we're going to change is the sign in front of I. Notice I didn't change the -4, just that -6i to plus. And we're going to do that in both places. So you're like, wait a minute. So you mean I got to FOIL twice on this? Oh, yes. Yes, you do. But we got some space here to work with. So I'm going to do the top first. And again, it doesn't matter which direction you put which set of parentheses, as long as they both get there. And again, I just multiply the edges of the box together to find out what goes inside that particular box. So really, it's nicer than FOIL because I don't see all these lines everywhere. I just have everything right there ready for me. And just remember again, what's I squared equal? Yeah, -1. So -1 times 48 makes this -48. So at this point, I go, okay, 28 minus 48 is -20. -42i and -32i. Again, I'm just combining like terms, no more multiplying. -42 minus 32 is -74i. And then I got one more box to do down below. But I want to tell you something a little special about this second one. I'm going to have you see it the first time But then we might be able to start saving ourselves a little bit of time after this. So once I get that set up, negative times negative is positive. I still got to be careful with that. Negative times positive is negative. Negative times negative is positive. And negative times positive is negative. And again, I always stop. I see an I squared. Negative 1 times negative 36 is positive 36. 16 and 36 is 52. But check out the i's. Positive 24 and negative 24. That'll happen in the denominator every time, because I don't want an I in the denominator. I'm going to be done. The only other thing I could do here, since these are all divisible by 2, I could go ahead and divide those all by 2 and then get my answer. Is it some work? Sure. Does it get you some good practice with dealing with your multiplication, your combining like skills, and dealing with this I squared thing? Absolutely, which is one of the reasons it really is helpful. Okay, so what if I go through that, because you'll get a chance to do that. Well, what if there's only a single number on top? Does that matter? Not really. I'm still just going to change the sign on I. So 9 plus 9i. 9 plus 9i. Cool thing here is I don't have to do with a box up top. I'm just going to distribute. So 27 plus 27i. But I do have to do my box down below. Again, just make sure each one gets along an edge. We're going to multiply what's outside the boxes. And if you need the calculator to multiply to fill in the box, that's okay. Negative 81 times negative 1, because that's what I squared is a positive 81. 81 plus 81 is 162. Positive and negative 81 cancel. Sweet. You're like, I don't know if anything goes into 27 and 162. There's one way to find out. Let's see here. What about 3? Let's try 3. Ooh, now that looks like that's divisible by 3 again. So let's try a bigger number. Let's try 9. Ooh. Wait a minute, 162. Oh, 27 goes into all of them. Well, hot dang. So I can divide everything here by 27 and get down to my answer. Now again, if this is a problem on a quiz, it's a 2-point question. If you get to here and then leave it, it's going to be like 1/2 off of 2. It's going to be next to nothing. So don't freak out and panic about that. But if you get it down there, that'd be nice. Okay. Last thing we're going to look at with quadratics. And then we're going to have a nice chunk of time for you to knock some of this out and be feeling good going into this quiz. All right, graphing the quadratic. Determine whether the solutions are found above or below. We'll talk about that. Highlight the area, write the interval notation. Okay. We're going to graph us some parabolas here, more of them. Number 1, got to have my vertex. Vertex. See, we're being repetitive, so it kind of gives you a chance to kind of have it sink in some more here. So my B value is 10. My A value is -1, because I always need those two values anyway. So the opposite of B over 2 times -1. My x value is 5. Now again, I have choices. At this point, I can come over to the calculator and say, okay, I'm going to plug 5 in over here. So negative, because it was in my original, so I got to keep the negative outside the parentheses. Okay. So my y value is 0. So my vertex is at 5, 0. Okay. Now again, this time, a value is a 1 or a negative 1. I can use the pattern, or I can plug it in the calculator. I can either go down 1 and over 1 each way, and then go down 3 and over 1. Solid line. Now this time, I don't have to shade. You're like, wait, what? I don't have to shade because I'm trying to figure out the interval in which my solutions are going to be. So, if it's greater than 0, I'm looking for the part that's above the x-axis. You're like, well, wait a minute. Above, there's nothing else that's above. It's this point right here. That is the only point, Harty, that would work. So this is going to be weird. I know, of course, I have to choose a weird one for number 1, right? If you just have a single point on there, you just write the point. You're done. Now, I promise they're not all going to be that weird. I promise especially on number 3 when we get there in a minute isn't going to be that weird in some of the other ones that we're doing. So just something to kind of keep in mind. Okay? But with these, again, I'm just going to look for the part that they have something for my solution. You're like, wait a minute, you gave us another weird one. Okay, well, let's see why this is weird. There's no x value. There's no b. What if I don't see a b? What is my b value? Yeah, it's 0. So my vertex is going to be negative b, or just 0, over 2a. 0. Okay. And 0 minus 9 is negative 9. So my vertex is at 0, negative 9. And you're like, okay, can I use the pattern? Is my a value 1? Yep. Up 1 over 1. Now, here's one thing I want you to pay attention to on this, though, because I'm going to have to be a little bit careful. I need my x-intercepts on these. So here's what we're going to do to try and help you out on this. And I'm even going to write some hints up of this on the board tomorrow when we're doing the quiz. Good that I've got my equation, but I'm going to go ahead, I'm going to type it in. And I'm going to go to the table. And I'm looking for the places where y equals 0. So my x-intercepts, let's see, I got one at negative 3. Let's see if I can find another one here. Oh, there's another one. And 3. Negative 3 and 3. I'm going to go ahead. I'm going to draw that in. Okay, this time we get to see some things at work. Determine where the solutions are going to be. Okay, again, if it says greater than 0, it means it's going to be above. So here's where my answers are going to be. So I need to write interval notation to show where those answers are. You're like, okay, well, since this is going to keep going out and up and out and up, and it's going to keep going and going and going, I'm going to start at negative infinity, and I'm going to keep coming until I get to this point, which is negative 3. I'm going to close it off. And then I'm going to lock that together with my second part, because nothing shaded, nothing shaded. Oops, start again. At 3, and go forever and ever and ever and ever and ever and ever up and out to the right. So you're like, okay, so if it's above, it's going to look kind of like this. Yeah, I got to pay attention to things like that a little bit. Okay? So that's one thing that we're looking at. One other thing I'm going to tweak here to make life easier on you. And number 4, make that x squared a plus. Okay, we're going to make this a little bit easier than having to deal with all the negatives. I wouldn't do that to you on a quiz anyway. So change that to a plus. We're going to do one more here because I do want to give you some time in here to be working on these a bit so you can get some practice. So, okay, number 5, last one. I want my zeros. You're like, is that all you care about? No, it's not all I care about. Get my vertex, then we'll get my zeros. My b is -4, my a is 1. So x equals the opposite of -4 is 4 over 2a. Okay, so my x value is 2. So I'm like, okay. If I type this in, okay, there's my vertex. So my y value is -9. And I'm going to go ahead and I'm going to put some of these other dots in. And I noticed something. I want the intercepts, and I see them right on the screen already. That's kind of nice. So go ahead. I'm going to get the other dots in that I see on my screen. Especially those intercepts, that's going to be nice. Connect my dots. So once you find the vertex on these, it's fine to use the chart, especially since that's where you're going to see your zeros at. So for these, my x-intercepts are at -1 and 5, here and here. So then I look and I see the less than sign. So I flip back over the other page and I go, ooh, less than means we're going to be looking at it below. So I'm looking at this part. So when I look below, I say, okay, well, where does it start? It doesn't start at infinity, it starts right here. It starts at -1. So I go -1. I follow it around until it stops, and it stops here at 5. I'm done. So when it's below, it's just going to be a real short interval notation. If it's above, if it's greater than, it's going to be greater. Now again, try some of these out. Tomorrow we're going to have a quiz. Looks fairly similar. I will tell you in advance to help. When you get to the part we're working on here, I will have this part up here, up on the board, to try and help you out, to give you some guidance. I'm not going to write the vertex formula, the -b over 2a. You need to know that, okay? But otherwise, just some graphing. I might even put up that I squared equals -1. We'll see. But give this a shot. This is online. Key up front. Work hard on this. Let's do this good going into next week.